Hey guys, welcome. This is our 7.2 video. Let's go ahead and get started. Again, like I mentioned, our notes are critically important. We want to make sure that we know our vocab. If we don't know our vocab, we're really going to get behind. So let's make sure we get through all this together. So we're going to highlight all this good stuff. So our first one, we want to write down all of this. Similar figures have the same shape, but not the same size. You can abbreviate as is similar to with the symbol with that little squiggly guy. So that little guy we're going to be using a lot. So it just kind of looks like whoop if I were to enlarge it. Next thing, so similar figures, we're going to be talking primarily about polygons, and those are two similar polygons, and we're going to match those up with corresponding angles and congruent if the lengths of the corresponding sides are proportionate. So we are going to go ahead and write all of this. So notice we have angles that match up, and we also have sides that match up. So what we want is we want the angles to be congruent, and we want the sides to be proportionate. So we're going to use proportions to help us out with this. Okay? We're also given sometimes extended proportions. Okay, so if we look, I'm going to scroll this down here. Let me see if I can get that. There we go. So we want to write this down as well. Extended proportions are when we continue the portion throughout the whole thing. So we want you to write that guy down too. Just when three or more ratios are equal, you can write it as an extended proportion right there. And a scale factor. A scale factor is a ratio of corresponding linear measurements of two similar figures. The ratio of lengths of corresponding sides, BC and YZ, or more simply stated, the ratio of corresponding sides. So that is key. The ratio of corresponding sides is kind of what we're looking for in scale factor. So you want to write that down. Okay? Alright, almost done with our vocab. We're going to be using our vocab often within our terminology. So let's go ahead and we got to skip a page or two around. So moving and grooving over to, I believe we should be one more page. And here we go. These are our last two. A scale drawing. A scale drawing is a drawing that we can use a scale to help us. So all lengths are proportional, so they're given corresponding actual lengths. And the scale is the ratio. So we're going to actually go over this example. So you want to go ahead and write that down right there. So those two sentences. Okay. Let's jump into some examples. I am on the wrong example. Boom, boom, boom. Here's our first one. Okay. Are the polygons similar? If they are, write a similarity statement for the given and the given scale factor. Okay, so we're looking over here. Please write down this question, okay, and write down the picture. Just looking at the picture, we can kind of assume where things are at. Like, for example, it looks like L and V match up. We don't want to look off of the picture. Instead, we want to look off of our congruency statement if we're given one. For example, W should match up with M, and so that's how I can see that these match up. They also have congruency marks on them. And then the last, sorry, I think I accidentally paused it, so let me rephrase myself. We also want to go ahead and make sure that we line up our correct side lengths. Okay, and another way we can do this is, for example, TU should match up with JK. So here's JK, here's TU, so we know those are a match. So let's see, are these polygons similar? The first thing we have to do is check to make sure their angles are congruent. If we look at our picture, all the corresponding angles show congruency, and we have a 90. The next thing we have to do is check for side length. So I'm actually going to let this go forward and write this stuff out. So, boom, 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 boom. I don't want you to write that. Okay, so here we go. Let's stop right there. So, go ahead and I want you to write this portion right here. Step 1, we identify pairs of congruent angles. So we did that. Then we're going to compare the ratio of corresponding sides. So we're going to do JK, like we talked about. JK corresponds to TU. And so we're going to do JK to TU. And we're going to compare those sides. And let's move it forward just a bit. Okay, so that's 12 over 6, which is 2 to 1. So now we want to go ahead and compare the next side. So here we have KL compared to UV, and KL to UV is 24 to 16, we get 3 over 2. Now, before we even do any more, we're going to do the rest, but before we do any more, notice these are already different. If we have different ratios, that means these are not to scale. Okay, so we do not have a correct one. If they were to ratio, then we would have our scale factor. So we kind of already know that these two polygons are not similar because 1/2 and 3/2 are not the same. Okay, so let's continue it on, just check all the other ones. Boom, 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 boom. And we see we have all four, 2/1, 12/7, 3/2, 1/1. We clearly do not have a similar polygon, so we'd say the polygons are not similar. Okay? So if these were to all match up, then we would say yes, and that would be our scale factor, but they do not match up, so that we say no, not similar. All right, let's move on to our next problem. So we got 3 problems. Okay, we have, look at this. See this symbol right there? This symbol right here means it is similar. So we already know that they're in proportion to each other and their corresponding angles are congruent. So we're given that right away. Okay, but it asks us, what is the value of x? So here's x right here. Well, how am I going to do this? The best thing to do is mentally in your mind try and take the 2 images and separate them. Now, luckily, we don't have to mentally do that. We can physically do that. So actually, we're going to go ahead and pull them apart. That's what that says right there, basically. So we're going to start by separating the 2 figures out. So my head's kind of in the way. I'm going to move up here. All right, so we separated the 2 figures out. Now we can easily say that 6 and 9 correspond. Now these 2 are the most important because they both have actual values. And we can actually pull our scale factor from them. 5 and y, we can't pull a scale factor because we don't pull numbers, and x and 7.5, we can't. So if we continue this problem on, we want to go ahead and set up a proportion to solve this. So what we're going to do is we're going to say, all right, we're going to go from the small shape to the large shape. And I'm going to keep that ratio in mind because if we mix up the ratio, it can go mix up. So 6 should correspond to 9. Since we know all the ratios are equivalent ratios, unlike our last problem where they were all different, we know they should be proportionate to one another. So I compared 6 to 9, and I want to find x, so I compare x to 7.5. We got to make sure we put x on the top because small goes on top, large goes on the bottom. Once we have this, all we have to do is solve a proportion. So we get 9x equals, and then here I'm going to do 7.5 in my calculator, times 6 gives me 45, and then divide by 9, x equals 5. And there's our correct answer. Okay? All right, last problemo. So make sure you drew those, by the way. Yeah. Okay. Last problem. Okay. All right. The diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the 2 towers is the main span. What is the actual length of the main span of the bridge? Well, when we're looking at a picture like this, it says 1 centimeter equals 20 meters. So what I basically have to do is say, well, how far is it from the 2 towers? Okay, so I have to measure this. That's kind of tricky because I don't have a ruler, so I probably can't do this problem. Or do I? I have a ruler. So I can actually go ahead and measure this. So I'm going to measure this, not on my screen. I'm going to do the one in the book because that's the one I'm supposed to be using. And it looks like we're doing this in centimeters. So I'm measuring this, and it looks like I get about 6.4. So the distance here is 6.4. Again, you couldn't do this unless you had a ruler. So we might need rulers. I don't know. So we get 6.4 centimeters. And so what we want to do is we want to go ahead and figure out how am I going to do this. Well, my scale is a 1 to 200. Now, again, remember, we usually like to keep ratios with the same units. Well, this doesn't have to be the case if we're using a scale drawing like this, because we can actually go ahead and figure out what the distance is in meters of the actual bridge by using different ones. But notice how I lined up the centimeters on the top and the meters on the bottom. So I'm comparing the drawing to the actual. Okay, and we can go ahead and cross multiply here, and we're going to get 6.4 times 200. So we get 1280 equals x, because x is technically 1 times x is x, and 1280 is in meters, and we're done. What's the actual length? And there it is. Alright guys, hope you enjoyed, and hasta luego.